Welcome to this comprehensive and beginner-friendly guide on C# code profiling and performance analysis. We'll explore how to identify and resolve performance issues in your applications. Code profiling is an absolutely crucial process for building highly efficient and responsive C# applications. It systematically helps developers identify and pinpoint performance bottlenecks that can hinder user experience. This essential process involves meticulously analyzing an application's runtime performance to precisely pinpoint specific sections of code that consume the most system resources, such as CPU and memory. Specifically, this detailed analysis process provides invaluable insights into critical metrics like CPU usage, memory allocation patterns, and the precise execution time of different methods within your application. Ultimately, thorough performance analysis ensures that your C# applications run smoothly, operate efficiently, and consistently provide a significantly better and more satisfying user experience for everyone. By effectively identifying and resolving these performance bottlenecks, you can significantly improve an application's overall speed, responsiveness, and its ability to handle increased workloads. To illustrate these concepts practically, let's begin by setting up a simple sample C# project. We will intentionally include some inefficient code within it for our profiling exercise. This deliberately inefficient project will serve as a practical, hands-on example for us to profile, analyze, and ultimately optimize throughout the course of this entire tutorial. Visual Studio's built-in diagnostic tools are seamlessly integrated directly into the IDE, offering a suite of powerful and accessible profiling capabilities right at your fingertips. These invaluable tools allow C# developers to gather crucial performance metrics and detailed insights while actively running their application in a controlled debug mode environment. The versatile Diagnostic Tools window within Visual Studio features several key tabs, including dedicated sections for CPU usage, memory usage, events, and various other performance-related metrics. CPU usage profiling is a fundamental technique that precisely measures the amount of CPU time consumed by different parts and functions of your C# code during execution. To effectively utilize the CPU usage tool, it's recommended to strategically set breakpoints at both the start and end of the specific code region you intend to analyze for performance. Once you've run your application and collected data, the CPU usage tool then displays a comprehensive report, clearly listing all functions by their total execution time. This detailed report is incredibly helpful for quickly identifying the longest-running functions within your code and precisely pinpointing potential performance bottlenecks. Memory usage profiling specifically focuses on meticulously analyzing memory allocation patterns and proactively identifying any potential memory leaks that could degrade application performance. Specialized tools, such as the .NET Object Allocation tool, are designed to track detailed memory usage and identify the exact code paths responsible for allocating the most memory. Within the .NET Object Allocation tool, the call tree view visually shows the hierarchical function execution paths that allocate memory, effectively helping you trace the precise source of high memory usage. With our profiling results in hand, let's now proceed to demonstrate the process of optimizing our previously identified inefficient code based on these valuable insights. For this demonstration, we'll apply a very common and effective optimization technique, specifically using the string builder class for efficient string concatenation operations. Once you've applied your chosen optimizations, it's absolutely crucial to verify and confirm the actual performance improvement achieved through your changes. To verify, simply run the profiler again on your newly optimized code. This allows you to directly compare the new performance metrics against the baseline. Ideally, you should observe a noticeable reduction in CPU time or memory allocation, which will clearly confirm the success and effectiveness of your optimization efforts. Beyond the integrated Visual Studio tools, other powerful third-party tools exist, such as .trace by JetBrains, which offers even more in-depth performance analysis capabilities. .trace is excellent for helping you find complex performance issues and provides a highly detailed breakdown of execution time for various methods and functions within your application. The .NET Memory Profiler is another highly specialized tool specifically designed for efficiently finding memory leaks and comprehensively optimizing memory usage in your .NET applications. This tool helps ensure that there are absolutely no resource leaks and that memory usage remains optimal and efficient across all your .NET programs and services. Herview, a robust and versatile tool created by the expert .NET team, is invaluable for diagnosing a wide array of complex .NET performance issues. Herview allows for deep analysis of critical metrics such as CPU usage, memory consumption, garbage collection behavior, and overall wall clock time for your application. Benchmark.net is a powerful library specifically designed to transform your C# code into reliable benchmarks, allowing you to analyze its performance programmatically and systematically. This library is incredibly helpful for precisely identifying subtle inefficiencies and optimizing code for maximum performance through highly repeatable and consistent test runs. ANTS Performance Profiler provides highly granular line-by-line profiling capabilities for all types of .NET code, including your C# applications and libraries. Furthermore, it effectively visualizes SQL query and HTTP request performance statistics, thereby providing a truly comprehensive and holistic view of your application's behavior. Database profiling is essential for ensuring efficient and optimized interaction between your C# application and its underlying database system, preventing data access bottlenecks. This crucial technique helps you quickly identify and effectively fix slow-running queries and other database tasks that can severely bottleneck your entire application's performance. Once specific performance bottlenecks are clearly identified through profiling, a wide range of proven optimization techniques can then be strategically applied. Optimizing loops is an absolutely critical step in performance tuning, as they frequently represent a very common and significant source of inefficiency in many applications. To improve performance, always strive to avoid unnecessary computations or excessive memory allocations directly within your loops, as these can quickly add up. Boxing and unboxing operations, which convert value types to objects and vice versa, are computationally expensive and should generally be avoided whenever possible. By strategically using generics and well-designed custom interfaces, you can effectively help prevent boxing and significantly improve your application's overall performance. Asynchronous programming, utilizing the async and await keywords, dramatically improves performance, especially in I/O-bound operations that involve waiting for external resources. This approach allows your application's threads to remain free and available for other tasks while efficiently waiting for lengthy I/O operations to complete without blocking. Minimizing unnecessary memory allocations is crucial as it directly reduces memory fragmentation and significantly lowers the overhead associated with garbage collection cycles. Implementing object pooling and intelligently reusing resources can significantly minimize the pressure placed on the garbage collector, leading to smoother application performance. Carefully choosing the correct and most appropriate data structure for a given task can have a profoundly significant impact on your application's overall performance characteristics. For instance, consider using a hash set for extremely quick presence checks or a dictionary for highly efficient key-value pair mappings and lookups. When performing heavy or frequent string concatenation operations, it is always best practice to use String Builder instead of repeatedly using the string class. The String Builder class efficiently avoids creating multiple intermediate string objects in memory, which significantly improves performance, especially with many concatenations. To boost responsiveness, implement data caching, often using an in-memory cache, to store frequently requested data and reduce redundant computations. Caching effectively reduces time-consuming database fetches and other expensive operations, thereby significantly improving your application's overall responsiveness and speed. Leverage advanced types like span T and memory T to handle memory buffers extremely efficiently, often without allocating any additional objects on the heap. The Task Parallel Library, or TPL, can be effectively used for parallelizing operations, which significantly improves performance on modern multi-core processors by distributing work. A crucial best practice is to always use profiling tools to accurately identify bottlenecks before attempting any form of optimization, ensuring your efforts are targeted. Always measure performance in release builds, not debug, as the tools within the Performance Profiler are specifically designed and intended for this optimized configuration. It's important to understand that optimization frequently involves making careful trade-offs between code readability, long-term maintainability, and achieving raw performance gains. Implementing continuous profiling practices helps you catch subtle performance issues early in the development cycle, preventing them from escalating into major, costly problems. To achieve the greatest impact, always focus your optimization efforts strategically on the specific areas of your code that consume the most system resources. To begin the profiling process, first open your C# project within Visual Studio, and then ensure you set the solution configuration to release for accurate measurements. Next, open the powerful Performance Profiler tool by navigating through the menu. Select Debug, then Performance Profiler, or simply press Alt plus F2. From the Profiler window, carefully select the specific profiling tools you need, such as CPU usage or memory usage, and then click the Start button to begin data collection. Once profiling has started, run your application through the specific scenario you intend to profile, ensuring all relevant code paths are executed, then stop the collection. After data collection, meticulously analyze the collected data and detailed reports to accurately identify any performance bottlenecks present within your C# code. Based on the precise insights gained from these profiling results, implement the most appropriate and effective optimization techniques to address the identified issues. Finally, and crucially, run the profiler once more on your optimized code to thoroughly verify and confirm the performance improvements you've successfully made. By diligently following these established guidelines and effectively utilizing the appropriate profiling tools, you can consistently profile and optimize your C# code with great success. Ultimately, this meticulous process leads to significantly enhanced application performance, resulting in a much smoother and more satisfying user experience for all your applications.